In this session chair, I request Ms. Karthika VATL for her topic like distributed estimation based on PKI for in-vehicle network security. So I request Ms. Karthika.
Good morning, everyone. I'm Karthika from CDAC Bangalore, and this is a collaborative paper with TVS Sensing Solution, Kalasangalingam Academy of Research and Education, and CCA. So as we all know, in-vehicle network comprises of at least 70 plus ECUs and various other components. And as the cyber physical systems are evolving and software-defined vehicles are evolving, there is going to be more electronic and software components within the vehicle. There is a need for having lightweight cryptographic schemes that has already been highlighted in various previous presentations as well. But the identity of these components also becomes important. In this work, what we have attempted is to use the cyber physical variables that exist in these components, which are dynamic, which keeps changing, and how can we leverage that in order to ensure the layer of security. So let us consider the scenario. I have a network of components A, B, C, and I have M, and M keeps sending data to A. And M may be, can be malicious, may not be malicious, but A wants to check why is this device is sending me this data. So how do I ensure this kind of, can I provide a mechanism? So one is M can be a spoof, or it may send some garbage data just to do a denial of service. How can I trust M? So here microcontrollers that are there have very limited hardware, and also the algorithms has to be fast enough. And we have attempted to use cyber physical data and then proposed a distributed estimation based technique. What is cyber physical data? All these components that are going to be there in a vehicle, it is going to store some data which is very specific to vehicle at that time point. It may be temperature, speed, odometer value, which keep, or many other variables that are there within the vehicle. Each of these variables are going to change from one time point to another. Can I use this variable, which is dynamic, in order to establish this trust between these nodes in the network? For this, we use this concept of relative measurements. At any given point of time, the node will know its relative measurement with its neighboring node. So let us consider there is a node N1, N2, and N3. And then node N1 is a neighbor of N2, N2 is a neighbor of N3. So all three of them, let us assume they have temperature values, and node N1 ranges from 0 to 40 degrees, N2 ranges from 0 to 80 degrees, and N3 from 20 to 30 degrees. And they know how they are relative to its neighbor nodes. So N1 knows that N2 can either have a value that is equivalent to N2, right? So it is either equivalent to itself, or it can have a value which ranges between 0 to 80 degrees. Because of this range that they know that, so N1 knows that it can be either equivalent to N2, or it can have a value which is at most that it can be vary between 0 to 80. Similarly, N2 knows its relative measurement to N3. So these relative measurements are used for establishing this trust when I'm in a doubt. Now this relative measurements, I always know, so if I have a neighbor, I will always know that I am +2 ahead of that neighbor, or -2 below my neighbor for this specific data. So I can store multiple data. I may have temperature data, I may have speed data, I may have many such cyber physical variables stored in me, and I always know relative to my nodes in the nearest neighbor, what is my variable relative to that particular node. So we use this graph structure that exists within this network and create this probing system around these cyber physical variables. So for example, I'm not going to use just one variable here. I'll be using a group of variables. Like I create a vector of variables, maybe speed, temperature, and timestamp. And I can also define the probing order. So if there is a node M which is trying to connect to me, then I can ask my trusted root. So there is, I'm introducing this concept of trusted root, which many frameworks do. But how is the trusted root going to establish this mechanism in this relative measurement scenario? So that is what we have worked out over here. So this probing vector and the probing order is sent to my trusted root when a node M tries to connect to me. And trusted root will tell me that, no, there is a node E1 and that node is relative to M in this certain fashion. So you can ask node E1 for its relative measurement with M, and you can ask M and compare its values, whether it is giving the same thing. If so, you can trust M. So this probing vector and probing order, I can keep changing. So I am E3 and I am sending a probing vector and probing order to M, and I can change the probing vector and probing order, and I can send it to E1 as well. So and along with M I am sending. So what E1 will give me is that the relation of it corresponding to M for that probing vector and order, and M also will give me this probe values, and this comparison will happen when if E1 is a trusted node. So there may be a case I don't trust E1, I don't know who E1 is. So how do I go about it? So if E1 is not a trusted node, I can keep asking the trust root that, possibly give me the next hop neighbor for E1 who I may trust, or the next hop. So this can keep continuing till I find a set of trusted nodes from this my root. So if T1, T2, T3 are the trusted nodes that I get, I can again choose whether T1 or T2 or T3 should be used in this as a path to go and probe E1. So this way, one more layer. So this can also be selected dynamic, so that one more layer is added into this security for probing the malicious node. If there is another scenario where the trusted root may inform that I don't have any information about him, I don't know who are the neighbors of him. So that time, of course, this node may be malicious. So we may have to do other PK mechanisms over here. Now, this distributed estimation, as I was saying in the initial, the relative measurement, it's not a linear equation. It will be a vector of values, and it is a matrix that will be formed based on the network, the trusted network that is already existing within the vehicle. So this is not a linear complexity problem which can be solved easily. So that adds the layer of difficulty in cracking what the challenge response mechanism that goes within this network. The implementation of this concept, to prove this concept, we have done with MQTT by mimicking these ECUs with node MCU modules, and using this one tested node will be there, which will have this graph, entire graph of the other nodes within the vehicle, and the subgraphs or the paths will be formed in dynamic fashion as and when a challenges or a probing vector is sent to the trusted node from one of those ECUs. Yeah, so this concludes my presentation. Any questions we can address this.
So there are two aspects in the automotive electronics.
Yeah.
One is maximum.
Yes. Correct.
Time synchronization is one of the most important things.
Hmm.
Like if you look at FlexRay protocols and things like that, if without doing that, if you say a vector, the time will differ. Without verifying the time synchronization, nothing will work.
A timestamp is also one of the variables in that vector. So I will ask for its relative measurement at a certain timestamp.
You have to have strong synchrony.
Sure, right, we will look into it. Okay, any other questions? If else, thank you for the opportunity to present it. Thank you.